All right, this is radioactive isotopes and the half-life. Now, ladies and gentlemen, our learning target is to be able to calculate the half-life of a radioactive isotope. And our success criteria for this video is to examine the rates of nuclear decay and be able to calculate the half-life of a radioisotope, the age of an object by using radiochemical dating, and the remaining amount of the isotope. Now, you should have this equation in your notes. If you do not, you need to get this equation in your notes. So I'll give you a second here to put this, because I can see people writing. They don't have this in their notes yet. Get this equation in your notes. So when we are calculating our half-life, all right, okay, we can do it mathematically as follows. AT right here, the amount left after T years. So this T is time, okay? It could be years, it could be days, it could be seconds, okay? AO right here is the initial quantity of the substance that is undergoing decay. Now, excuse me, this 1/2, okay? The T right here is the time we were just talking about. This T 1/2 is the half-life, and this, ladies and gentlemen, is an exponent, okay? So the time over the half-life is how we're going to use this equation to do the particular calculations, okay? Now, we won't always use this equation because sometimes we will not have enough of the information to use the equation. But we're going to do a couple of examples, and then I'm going to set you loose. So, go ahead and copy this into your notebook, and then we will discuss the problem. All right, the question states, if a 25-gram sample of nitrogen-16 undergoes 4 half-lives, how much of the original sample will remain? Now, we cannot, ladies and gentlemen, we can't use this equation. Why can't we? Well, we don't actually know what the half-life is. So we cannot use that equation. So, how I'm going to work this one is I'm going to start off with, all right, I've got 25 grams. And by definition, what is a half-life? Half of it decays, right? So, if I undergo 1 half-life, what's half of 25? 12.5. If I undergo a second half-life, 6.25. It's half of that, right? Yeah. Half of 12.5. Okay. 6.25. The third half-life, it's getting a little bit dicier here. So that's going to be 3.125 grams, and I should be putting grams here, labeling. So on my fourth half-life, I can't do that. Looks like 41. My fourth half-life, I take half of the 3.125, and it's going to give me 1.5625 grams. So if I were doing this and I'm looking and I say, okay, here's 25. This 4 is an actual number. I'm not going to count that. So I'm going to have 25, meaning 2 sig figs. So my answer is going to be, okay, 1.6 grams of the original sample will be remaining after I've undergone 4 half-lives. Okay? Any questions? Just taking a half and a half and a half and a half. All right? No, because what's 25 divided by 4? It's going to give you 6 something. Right? You'd have to divide by 2, then divide by 2, then divide by 2, then divide by 2. Okay? Huh? Divide by 4 2 times.
That's 6. That works, yeah.
Well, one thing you could do, okay, if this is half, okay, that's a fourth, that's an eighth, that's a 16th. So take 1/16 of 25. That would work. Now, here is our second example. So go ahead and copy this into your notes. The half-life of hafnium-156 is 0.025 seconds. How long will it take a 560-gram sample to decay to 1/4 of its mass? All right. Well, if we're looking at this, all right, if we're starting out with 560, all right, grams. The first 1 half-life is going to give me, the first half-life is going to give me, what's that, 280. The second half-life, and if you look at this, half-life and a half-life, that's going to give me my 1/4. Okay? So 1/4 of the original mass is going to be what? 140 grams is going to be 1/4 of that 560. But how many half-lives did that take? 2 half-lives. Well, if each half-life is 25 seconds, the total time it's going to take is 0.050 seconds. And that's what I was trying to answer. How long will it take? So it will take 0.050 seconds to get 1/4 of that original mass. Yeah. Two sig figs? That's an S. Seconds. Okay? No, that's an S for seconds. 0.050 seconds. Yeah, this is a seconds too. Go ahead and copy this. Potassium-42 has a half-life of 12.4 hours. How much of an 848-gram sample of potassium-42 will be left after 62.0 hours? Now, ladies and gentlemen, this is one in which we can use our equation. AT is equal to A0, 1/2 of the T over the T 1/2. I don't like that. So what I need to do is I need to fill some stuff in. Well, my AO here is 848 grams. My half-life is 12.4 hours. My time that it's actually undergoing is 62.0 hours. So now I can calculate what my amount left is. So what I'm going to do is 1/2 is really 0.5. So in my calculator, I'm going to have 0.5, and my exponent is going to be 62.0 divided by 12.4. Program that into my calculator. When I did that, I came up with a value of 0.03125. Now, I'm going to take that value and multiply that by the 848 grams. And when I do so, my amount left after 62 hours is going to be 26.5 grams. Okay? Now, the hardest part is to get this into your calculator right here, that 1/2 in the exponent. Okay? Now, this final problem, ladies and gentlemen, you definitely need to copy this down into your notebook because this is straight off the WebAssign, and we had a lot of questions with it when we did it in my other classes. So copy this one down. I'm going to show you how to work it. The half-life of chromium-51 is 30.0 days. What fraction of a sample of this isotope will remain after 24.1 days? Now, in order to determine how much remains of the particular sample, okay, on our equation, we had A with the time, A0, 1/2 T to the 1/2, right? Now, to get the amount that is remaining, the fraction, and I don't know why WebAssign says fraction, because they don't want a fraction, they actually want a decimal. All right, so I don't know why they said fraction, but nonetheless, when we're doing this, how we need to go after this example is just like this, right here. Just taking this part of it. So, 1/2 T over T to the half-life. Well, there's my 1/2. My T is 24.1 days. My half-life is 30 days. So, when I do my calculation, I'm going to take that 0.5 and I'm going to put that to the power of 24.1 divided by 30.0, and that's going to give me a value of 0.57302336. Okay, and I come back and I say, okay, here's 3 sig figs. I'm going to put this into 3 sig figs. So, how much will I have left after 24.1 days? That's going to be 0.573. There's not going to be a label. You won't have a label to that one, okay? But I did have a lot of questions over how to work this on WebAssign. So, that's how you do this particular one.